we will discuss about the subsum. Next is graphical representation of adsorption, absorption and subsum. What is the difference between adsorption and absorption? Next is examples of adsorption and absorption. Next, what is positive adsorption and negative adsorption? Next is types of adsorption. Types of adsorption, it is of two types: physical adsorption and chemical adsorption. Physical adsorption, types of adsorption, that is, first is physical adsorption, second is chemical adsorption. This thing we will discuss in this class. Clear? So we have to discuss these things. So let us first what is subsum. First we discuss what is subsum. What is subsum? Then the graphical representation of adsorption, absorption and the rest things. Clear? So first we will discuss what is subsum. What is subsum? This is a short question, very important question. So in surface chemistry, you have to understand the terms very clearly. Whenever you understand the terms very clearly, then you can go deeper into the surface chemistry. Otherwise, it is very difficult to go deeper. And when I will always keep focusing to understand the concept very clearly, so that you will go deeper into the surface chemistry. Otherwise, it is very difficult to go deeper into the surface chemistry. So slowly we are proceeding one by one, terms and concept. Clear? So what is subsum? Subsum is when both adsorption and absorption takes place simultaneously. That is called subsum. When both adsorption and absorption takes place simultaneously, then it is called subsum. When both adsorption and absorption takes place simultaneously, then it is called subsum. Very simple. When adsorption and absorption takes place simultaneously, we have to call this term subsum. Next, I will represent you graphically how the subsum, adsorption and absorption takes place with some examples. Clear? We will go deeper into the surface chemistry part by part. Clear? So subsum is when both adsorption and absorption takes place simultaneously, then it is called subsum. Clear? Next, I am representing the graphical. I am representing the graphical representation. I am representing the graphical representation of, that is, adsorption, absorption and subsum. Look at this. First, I am drawing the diagram. Look at this diagram, that is adsorption. This is adsorption. So what is adsorption? Water vapor gets adsorbed on the silica gel. In an example, I am writing first, then I will explain. Water vapor gets absorbed on the silica gel. Next is your surface film. Surface film. Next is absorb water according is to shear. Water vapor absorbed by Cl2. Look at this. So three things we have to discuss: adsorption, absorption and sorption. Look at adsorption. Look at here, water vapor gets absorbed on the silica. This is silica gel. On the surface of silica gel, water vapor gets absorbed. That is a surface phenomena. That is a surface phenomena, that is adsorption. This is the graphical representation of adsorption. Water vapor gets absorbed on the surface of silica gel. Next is absorption. Here carbon dioxide absorbed in water forming carbonic acid H2CO3. This is bulk phenomenon. Look at here, carbon dioxide gets absorbed in water forming H2CO3. Water vapor absorbed by calcium chloride. Water vapors are absorbed by calcium chloride. Clear? So this is absorption. The particles get uniformly penetrate throughout the body. That is absorbed. Next is sorption. When both adsorption and absorption takes place simultaneously, that is called sorption. So sorption of dyes takes place on cotton fibers. Suppose you are using the Ujala. This is the best example. Wherever you use the dyes Ujala, that both adsorption and absorption takes place on the cotton fiber. So whenever you use the white clothes, then you use the dyes, that is Ujala. Suppose you are using Ujala, that is both adsorption and absorption takes place. That is called sorption. So three things. First is adsorption. Here water vapor gets adsorbed on the surface of the silica gel. Absorption, CO2 gets absorbed in water forming H2CO3. Next, water vapor absorbed by calcium chloride. This is bulk phenomena. This is surface phenomena. Next is sorption. Sorption of dyes takes place on cotton fiber. That is, dyes are adsorbed as well as absorbed by cotton fiber. So whenever we are using Ujala, suppose Ujala जो dyes to the blue color dyes. So whenever you use the cotton clothes, you are using Ujala, then both adsorption and absorption takes place on this cotton fiber. Both adsorption and absorption. Adsorption means जोटा blue color का white ऊपर देखा जी वो सब that is adsorption, and जोटा absorb करना that is absorption. The solvent particle gets absorbed. So we will discuss the difference. Next we will discuss the difference between adsorption and absorption. So what is the biggest difference between adsorption and absorption? After that we will I will give you the example between adsorption and absorption. Very good example. First I am giving this example. Suppose practical example. Whenever you take when I take a white chalk, and dip into a ink. What is ink? So when I take a chalk and chalk is dipped in the surface, chalk is dipped in the ink. Chalk ink with it. So what will happen? The dyes gets adsorbed on the surface of the chalk. Whereas the solvent molecules that penetrate into the chalk, whenever I break the chalk, what will happen? The above surface, that will be blue color or black color, whatever the color of this dyes, and inside this chalk, that is white. Inside the chalk, that is colorless or white. But outside the chalk, that is blue or black. What is the color of the ink? So the ink or dyes gets adsorbed on the surface of the chalk, whereas the solvent molecules or colorless molecules that penetrate into the chalk. Whenever I break the chalk, that will white from inside. So the solvent molecule gets penetrated into the chalk, that is throughout the chalk, that is absorption. But whereas the dyes gets adsorbed on the surface of the chalk. Clear? So this is the graphical representation of adsorption, absorption and sorption. Next is the difference between adsorption and adsorption and adsorption. This is an important question. You may put this question: what is the biggest difference between adsorption and absorption? What is the difference between adsorption and absorption? Clear? So first we will write the definition of adsorption: the phenomenon of attracting and retaining any substance on the surface of another substance is called adsorption. The phenomenon of attracting and retaining any substance on the surface of another substance is called adsorption. Absorption, it is the phenomenon in which the particles of the gas or liquids It is the phenomenon in which the particles of the gas or liquid gets uniformly distributed throughout the body of the solids. So the phenomenon of attracting and retaining any substance on the surface of another substance is called adsorption. It is the phenomenon in which the particles of the gas or liquids gets uniformly distributed throughout the body of the solid. It is uniformly penetrate kariba. Suppose chalk, you will dip the chalk into this ink. So what will happen? The solvent particles or colorless particles that penetrate uniformly or penetrate uniformly into the chalk. So whenever you break the chalk, that you will find colorless from inside. But on the surface of the chalk, the blue color or black color of the dyes that gets adsorbed. Clear? Second part, it is a surface phenomena. It is a surface phenomenon. It is a It is a surface phenomenon. It is a bulk phenomenon. Look at it. It is a surface phenomenon. It is a bulk phenomenon. Next is it is rapid in the beginning. It is rapid in the beginning. It is rapid in the beginning and its rate slowly decreases. It is rapid in the beginning and its rate slowly decreases. It occurs at a uniform. It occurs at a uniform rate. It is rapid in the beginning, its rate slowly decreases, but it occurs at a uniform rate. Next, it depends upon the surface area adsorption. It depends upon the surface area. It depends upon the surface area. It is independent of the surface. It is independent of the surface area. It is independent of the surface area. Look at it. These are the important points we have to discuss. This is the very important question. This is the biggest difference between adsorption and absorption. First, the definition of adsorption: the phenomenon of attracting and retaining any substance on the surface of another substance is called adsorption, or the phenomenon or the process in which adsorbent gets adsorbed on the surface of adsorbent, that is called adsorption. The process by which the adsorbent gets adsorbed on the surface of the adsorbent is called adsorption. Or what is absorption? Absorption, it is the phenomenon in which the particles of the gas or liquid, gets uniformly distributed throughout the body of the solid. Suppose chalk. Take the best technique. I will give this example. I am writing this example also clearly because I am giving example first, then I am writing the chalk example. This is the best suitable example in order to understand adsorption and absorption. I think this is the best suitable example in order to understand the adsorption and absorption, because suppose the chalk, whenever we are writing this chalk on the blackboard, this chalk you will dip in a ink. You will dip this chalk into this ink. So what will happen? The blue color or black color of this ink, that is the dyes, dyes of the ink that gets adsorbed on the surface of the chalk. The dyes of the ink that gets adsorbed on the surface of the chalk, whereas the colorless particles, solvent molecules or colorless particles that gets absorbed throughout the chalk or bulk of the chalk, that is from inside. So whenever you break this chalk, what will happen? You will find the chalk is white from inside. So, but the solvent molecule penetrate, it will simply wet. So we can say that the chalk is white from inside, whereas outside the dyes gets adsorbed on the surface of the chalk. Clear? So in this thing, both adsorption and absorption takes place. So we can also take the example sorption. When both adsorption and absorption takes place, that is also sorption. So the dyes of the chalk that gets adsorbed on the surface of the chalk, that is adsorption. But whenever you break this chalk, you will find inside that is colorless or white. So that is absorption, because the solvent particles or colorless the solvent colorless of the ink goes deeper into this chalk. So that is absorption. So in this practical example, both adsorption and absorption takes place. That is also absorption. So chalk, the dyes gets adsorbed on the surface of the chalk, and the solvent or colorless particles goes deeper into the chalk. Whenever we break this chalk, that will found white inside. That will found white inside. Clear? So this is absorption. So absorption is a absorption which occurs or gas or liquid gets uniformly distributed throughout the body of the solid. It gets uniformly distributed throughout the body of the solid, and it is a surface phenomenon. It is absorption is a surface phenomenon, whereas absorption is a bulk phenomenon. Throughout the body it occurs, but absorption that occurs on the surface. Since absorption occurs at the surface, so it is a surface phenomenon, but absorption occurs throughout the bulk of the material. That is bulk phenomenon. That is bulk phenomenon. Next, it is rapid. Absorption is rapid in the beginning, and its rate, absorption rate, generally decreases. At the beginning, it is occurs fastly. After that, the rate its rate decreases. But similarly, absorption, but whereas absorption occurs at a uniform rate. Its speed is uniformly occurs. So it occurs at a uniform rate, but its rate slightly after it is rapid in the beginning. After that, its rate decreases. So next, absorption, it depends upon the surface area. It depends upon the surface area. Absorption, it depends upon the surface area. It is independent of the surface area. So absorption, it does not depend upon the surface area of the adsorbent. So surface area of the adsorbent. So this is the difference between adsorption and absorption. This is very important question. So you will write this 4 point. You will definitely get this mark. Next, explanation of adsorption and absorption. Explanation of adsorption and absorption. In absorption, first I am writing this theoretical part, then I will explain clearly. In absorption, the substance penetrates. In absorption, the substance penetrates into the bulk of the material. In absorption, the substance penetrates into the bulk of the material, that is solid, that is material or solid or liquid. That is bulk of the material, that is solid or liquid. So absorption, the substance penetrates into the bulk of the material, that is solid or liquid. Suppose chalk material that is solid. Into this chalk, into this chalk, the solvent molecules, I am writing this. First I will write this. When a chalk, take this example, where a chalk is dipped. When a chalk is dipped in the ink, when chalk stick when a chalk stick is dipped in the ink, the surface of the chalk stick become the surface of the chalk stick become colored. The surface of the chalk stick become colored because the colored molecules because the colored molecules or dyes gets absorbed on the surface of the chalk stick. It is because the colored molecules dyes gets absorbed on the surface of the chalk stick. Whereas the solvent colorless, whereas the solvent colorless of the ink, whereas the solvent colorless of the ink goes deeper into the stick, due to absorption. If we break the chalk stick, it is found to be white. It is found to be white from inside. It is found to be white from inside. Look at very important example, and this is the clear understanding of adsorption and absorption. In order to understand adsorption and absorption, I think this is the very vital example, and you can thoroughly understand it. Suppose we are to, in absorption, the substance penetrate into the bulk of the material or solid or liquid. Where, like this example, where a chalk stick is dipped into the ink. Suppose we will keep an ink into this, we will dip or we have to dip a chalk stick into this ink. Whenever we dip the chalk stick into the ink, what will happen? When a chalk stick is dipped into the ink, the surface of the chalk stick becomes colored. The surface of the chalk stick becomes colored. That is because the color molecules are dyes. So whenever you dip the chalk into the ink, the colored molecules or dyes gets absorbed on the surface of the chalk. the colored molecules or dyes gets adsorbed on the surface of the chalk. Because it is the colored molecules or dyes gets adsorbed on the surface of the chalk stick, whereas the solvent or colorless of the ink, goes deeper into the stick. What will happen? The solvent or colorless of the ink goes deeper into the stick. So solvent molecules ta kodi jibo deeper into the bhitor ku jibo solvent, whereas the solvent molecules or colorless of the ink goes deeper into the stick due to absorption. So solvent molecule or colorless molecule ta deeper jibo chalk stick bhitor ku, और dyes or colored molecule ta get adsorbed hobo surface upare. So dyes gets adsorbed on the surface of the chalk, whereas the solvent or colorless molecule goes deeper into the chalk. And throughout, this is absorption occurs throughout or bulk of the material, but it is the surface phenomenon adsorption, because dyes gets adsorbed on the surface of the chalk stick. So that is surface phenomena, but absorption is bulk phenomena, because the solvent or colorless of the ink goes deeper into the stick due to absorption, and if we break the chalk, whenever we break the chalk, we will find inside that is white. Whenever we break this chalk, we will find inside that is white. Clear? This is the best example so far in order to understand adsorption and absorption. This is the very simple and best example in order to understand the adsorption and absorption. More examples on I will give you the more examples of adsorption. More examples of adsorption. Examples of adsorption. I am giving one example. Suppose we have to keep O2H2Cl2 gas in a vessel containing powder charcoal. What happened? Containing powder charcoal. So when the gas, it is found that the pressure of the gas inside the vessel decreases, because the gas molecules of O2H2Cl2 gets adsorbed on the surface of the charcoal. So due to this, the pressure of the gas inside the vessel decreases. That decreases. Clear? So this is one example. First example, when gases like H2Cl2, O2, CO and NH3. When gases like H2Cl2, O2, CO and NH3 are taken in a closed vessel. When gases like H2Cl2, O2, CO and NH3 are taken in a closed vessel, what happens? Containing powder charcoal. Containing powder charcoal, what will happen? It is found that the pressure of the gas, gas inside the vessel decreases. It is found that the pressure of the gas inside the vessel decreases because the gas molecule gets adsorbed on the surface of the charcoal. On the surface of the charcoal. Look at very important thing. When suppose in a vessel, closed vessel, when gases like H2Cl2, O2 and CO NH3 are taken in a closed vessel containing powder charcoal. This is a powder charcoal. So when gases like H2Cl2, O2, CO, NH3 are taken in a closed vessel containing powder charcoal, it is found that the pressure of the gas inside the vessel decreases because the gas molecules gets adsorbed. The gas molecules gets adsorbed here. Since the gas molecules gets adsorbed here, the pressure here the gas molecules gets adsorbed here. So the pressure of the gas inside the vessel. So the pressure of the gas inside the vessel decreases. So the pressure of the gas inside the vessel decreases because due to the adsorption of gas molecules on the surface of the powder charcoal. Because due to the adsorption of the gas molecule on the surface of the powder charcoal. Since the gas molecules here, this is a vessel, closed vessel containing powder charcoal. Whenever gas lines are closed, whenever we close the gas line H2Cl2, O2, CO, NH3, etc. any gas. So this type of gas, so what will happen? The gas molecules gets adsorbed on the surface of the powder charcoal. Whenever the gas molecules gets adsorbed on the surface of the powder charcoal, what will happen? The pressure inside the gas decreases. The pressure inside the gas decreases due to the adsorption of the gas molecules on the surface of the powder charcoal. Clear? This is the best example of adsorption. Another example, the air becomes dry. Second example. The air becomes dry. In this second example, look at the air becomes dry in the presence of silica gel. This is one of the simplest example also you can write. The air becomes dry in the presence of silica gel because silica gel adsorbs water molecules. Since the silica above the surface of the silica gel, water molecule gets adsorbed on the surface of the silica gel, so the air becomes dry. This is one of the best example of also adsorption. Third example, we can take it the adsorption example, simple practical example. I am giving one practical example that listen. In temples, we are using the raw sugar, that is gudo. Gudo টাকে আমি ইউজ করছি টেম্পল মন্দিরে, কিন্তু চিনিটাকে ইউজ করব না, সুগারটাকে ইউজ করব না। মন্দিরে দেখো ভোগ লাগে চিনিটা ইউজ করি, গুড়ো ইউজ করছি। What is the reason behind it? The reason behind it is that raw sugar, that is raw sugar যেটা গুড়োটা তার কালারটা আসিব ব্ল্যাক কালার আসিব, সেইটাকে অ্যানিমাল ব্যাড তার অ্যানিমাল হাড়া উপরে তাকে অ্যাডজস্টন করে, অ্যানিমাল হাড়া উপরে যেহেতু অ্যাডজস্টন হয়, ସେଥିପାଇଁ ତାକୁ ୟୁଜ୍ ବୋଲି ମନେ So this is the best reason behind the why we are not using raw sugar in temples, but we are using this general sugar. No, we are using the raw sugar in temples, but we are not using the general sugar in temples, because in order to prepare the general sugar, the white color, we have to do adsorption. We have to do adsorption on the beds of charcoal, on the beds of charcoal, animal charcoal, because एनिमल हाड़ उपरे ताको एडजस्टमेंट प्रोसेस टा करा जाय जेहेतु एनिमल चार्कोल उपरे एडजस्टमेंट प्रोसेस हबो तनो एनिमल हाड़टा इट इज प्रिवेंटेड इन हिंदू कस्टम्स सो वी आर नॉट यूजिंग द जनरल सुगर इन temples but we can use it we can use this general sugar for our consumption but we are not using the general sugar in temples because this in order to prepare the general sugar we have to do adsorption process the raw sugar which gets adsorbed on the beds of animal charcoal to converted to white sugar or general sugar. So when if the adsorption occurs on the beds of animal charcoal in order to prepare the white sugar or general sugar, so it is prevented in using as a in temples, using in temples. So I can write aqueous solution. Simple, we can say that raw sugar is goda color, dark color. Aqueous solution of raw sugar is dark color. Second, third example, aqueous solution of raw sugar is dark color. Aqueous solution of raw sugar is dark color. When this dark color solution is passed over the beds of animal charcoal. When this dark color solution is passed over the beds of animal charcoal then the solution becomes colorless. Then the solution becomes colorless because the coloring material, coloring substances or material gets adsorbed on the animal charcoal. So this is the best example. Simple गुड़टा यूज होची मंदिर रे किंतु चीनीटा यूज हो काई गुड़र कलरटा कोन रो कलर डार्क कलर सो ई जे एक्वा सॉल्यूशन ऑफ रॉ सुगर गुड़टा सेटा जदी तुमे एनिमल चार्कोल ऊपर ताको एडजस्टमेंट प्रोसेस रे एडजस्टमेंट करा होची एडजस्टमेंट करके चीनी को कन्वर्ट करा होची सो दिस विल बिकम ड्यू टू एडजस्टमेंट aqueous solution of raw sugar is dark color. When this dark color solution is passed over the beds of animal charcoal beds pass kara jibo kon hobo na the solution become colorless. Solution ta colorless is because the coloring substances or material gets adsorbed on the surface of the animal charcoal. The animal charcoal upre se kon hobo adsorption he jibo. The dark color solution or dark color dyes or any dyes to color particles that will get adsorbed on the surface of the animal charcoal. Due to this raw sugar which is dark color that become colorless. So this is the best example of adsorption. Next, there are two types of adsorption. One is positive adsorption and second is negative adsorption. One is positive adsorption and second is negative adsorption. Positive adsorption. Positive adsorption when the concentration of the adsorbent is more than when the concentration of the adsorbent is more. So when the concentration of the adsorbent is more on the surface of the adsorbent, when the concentration of the adsorbent is more on the surface of the adsorbent, when the concentration of the adsorbent is more on the surface of the adsorbent than in bulk, then in the bulk, it is called positive adsorption. Then it is called positive adsorption. Just when the concentration of the adsorbent is more on the surface of the adsorbent than in the bulk. Negative, when the concentration of the adsorbent is less on the surface, when the concentration of the adsorbent is less on the surface of the adsorbent. Negative adsorption. Negative adsorption when the concentration of the adsorbent is less on the surface of the adsorbent then in the bulk, when the concentration of the adsorbent is more on the surface of the adsorbent than in the bulk, it is called positive adsorption. When the concentration of the adsorbent is less on the surface of the adsorbent than in the bulk, it is called negative adsorption. So when the concentration of the adsorbent is less on the surface of the adsorbent, so suppose we have to, this is the adsorbent, this is the material surface, that is adsorbent, that is adsorbent. We have to keep the adsorbent. On the surface of adsorbent. Whenever we have to keep the adsorbent on the surface of the adsorbent, what will happen? The concentration of adsorbent is more than on the surface of the adsorbent. When the concentration of adsorbent is more in comparison to adsorbent, that is positive adsorption. When the concentration of the adsorbent is less, then when the concentration of the adsorbent is less on the surface of the adsorbent, then in the bulk it is called negative adsorption. Simple. When the concentration of adsorbent is more in comparison to adsorbent, that is positive adsorption. When concentration of the adsorbent is less on the surface of the adsorbent concentration high, positive adsorption. adsorbent concentration low, that is negative adsorption. Here, next is types of adsorption. There are two types. Next class we will discuss about the types of. I am only writing the types of adsorption. Next class we will proceed. What are the physical forces or what are the forces which operates between the types of, and 1 minute. Next is types of adsorption. Types of adsorption. There are generally two types of adsorption. Adsorption is of two types. One is physical adsorption. Second is chemical adsorption. So types of adsorption. It is of two types. First is physical adsorption. Second is chemical adsorption. Physical adsorption, it is good short terms. Phibsorption, chemsorption. We will discuss next class. So types of adsorption, it is of two types: physical adsorption, chemical adsorption. Physical adsorption is called phibsorption, chemical adsorption is called chemsorption. And what are the classification is based on the types. The classification is based on the types of force operating between adsorbent and adsorbent. This physical adsorption and chemical adsorption is divided. The physical adsorption and chemical adsorption is based on the types of forces operating between adsorbent and adsorbent. So clearly, first class topic 1, you should first thoroughly read this what is adsorption, adsorbent and adsorbent. If you do not clear this thing, you cannot proceed into the surface chemistry, deeper into the surface chemistry. So I focused on these three terms: adsorption, adsorbent and adsorbent. I have repeatedly explained this thing because these three are very fundamental thing in order to go deep into this surface chemistry. So if you cannot understand these three terms, also adsorption, you cannot go deep into this surface chemistry. So adsorption is of two types: physical adsorption, chemical adsorption, and the forces which operates between adsorbent and adsorbent, depending upon this, it is classified two types: physical adsorption and chemical adsorption. Next class we will discuss the physical adsorption and chemical adsorption.